solving elementary exponential equations, and sometimes this is referred to the common base method. So depending on your textbook, it may say solve exponential equations using common base. And what that means is if I can find a common base, something like this, if I say a to the x equals a to the b, well look, my common base is a, and I have a to one power equals a to the other power, which must mean that I can drop the bases and just set the two exponents equal to each other. And that's how we'll solve these exponential equations. Now remember, exponential equations are a little bit different because factoring and all those techniques we've gone over don't exactly work here. But this is our first approach, is by setting a common base and then being able to drop the bases and set the exponents to be equal to each other. Alright, so in trying to solve an elementary exponential equation, the first step you need to do is isolate your exponential. In other words, get your something to the x power by itself. For in this example 1, we have solved 2 to the x minus 8 equals 0. Alright, so I need to get 2 to the x power by itself, so I have 2x equals 8. From there, I need to try to find a base that will work for both sides. Now this example is a good one to get started with because it's pretty clear here that 8 is actually 2 to some power, right? This is here, now we have 2 to the x equals 2 to the third power, right? 2 cubed is 8. So now I'm trying to figure out what x is. 2 to the x power equals 2 cubed. I'm allowed to drop these bases now and set x to be 3. And so there's my solution. X equals 3. And you can imagine that it does work because if I plug it back in, 2 cubed minus 8, well, 2 cubed is 8, so I have 8 minus 8, and that equals 0, and that's exactly what we wanted. So it did work. Okay, so this is an easy example of equating or finding common base. I'm going to go over several examples. Some of them are easy, some of them are not so much. But I'm going to go over all the different tricks, and I hope this makes sense. So let's take a look. Okay, so in example 2, we have the following exponential equations. For part A, we have 9 to the 2x minus 5 power equals 27 to the x minus 2 power. Okay, now we're going to apply our steps. First, we try to get our exponentials isolated, which we have. The second thing is, and this is the most important step, is can we find a common base? Can I write 9 and 27 as something to some power? Honestly, this comes with some practice. You'll start seeing that several of these numbers show up often. For example, 9 and 27 both show up often. I remember now that 9 is the same thing as 3 squared. So instead of writing 9 to the 2x minus 5 power, I'm going to write 3 squared to the 2x minus 5 power. And 27 is actually 3 to some power as well. It's 3 cubed. 3 times 3 times 3 is 27. So I have 3 cubed to the x minus 2 power. So I almost have a common base. I just need to be able to write these as 3 to some power. And I can do that because I remember my exponent rules. Remember, if I'm raising 3 squared to the 2x minus 5 power, that's the same as 2 times 2x minus 5. 3 to the 2 times 2x minus 5 power. And similarly, on the other side, I have 3 to the 3 times x minus 2 power. So once I distribute my 2 and my 3, I have 3 to the 4x minus 10 equals 3 to the 3x minus 6. From that point, I'm allowed to not worry about my bases. I don't have to consider the 3 anymore. Don't say it cancels. They don't cancel. The idea is now that I have a common base, I can go from an exponential equation down to a linear one because the exponents have to equal each other. So here I have 4x minus 10 equals 3x minus 6. And this is just a simple linear equation, right? I subtract the 3x from both sides to get 1x on the left, and I add 10 to both sides, so I get 4 on the right. And you can always plug that in into the original equation to see if you get what you wanted. Alright, now for part B, we'll do a similar thing. I have 2 to the x plus 1 equals 64 cubed. Now 2 is prime, so that allows me to know that 2 is my common base. However, now I gotta think, is 64 2 to some power? Alright, so what I know is 64 is 8 squared, and 8 squared is 2 cubed squared. So that means that 64 is 2 to the 3 times 2 power, which is 6 power. From that point, I have a common base, so I can just consider the exponents and end up with x plus 1 equals 6. Remember, I didn't cancel out my bases. It's just now, since I have a common base, I can just equate the exponents. And so I get x equals 5 as my solution. Alright, so we'll do the same thing in part C. 2/3, 2 and 3 are both prime, so I know I can't write them as something to some power. The 9 and 4 do look familiar, don't they? I mean, isn't 9 3 squared and 4 2 squared and have all that to the negative x power? Well, 3 squared over 2 squared is the same as 3 halves squared to the negative x power. And I almost have a common base, right? I have 2/3 on the left, I have 3 halves on the right. They're reciprocals. But remember, I can make that a reciprocal by making it negative. So I have 2/3 to the x plus 3 equals 2/3 to the negative 2 times negative x, which gives me a positive 2x. Okay, so remember, I'll make a note of that. I said negative 2 because of the reciprocal times the negative x, and that's how I got positive 2x. From there, because I have a common base, all I need to do is consider my exponents. I can equate the exponents together. Because 2/3 to this power has to equal 2/3 of that power, so those two powers have to be the same. And this is just a simple linear equation. I can subtract x from both sides, and I end up with x equals 3. And there we have it. All right, let me show you a couple more. Okay, in part D here, we have 7 to the x squared plus 3x equals 1 over 49, and the 49 jumps out at us immediately, right? So I'm thinking that this is 7 to the x squared plus 3x power, and that equals the 49, I'm thinking 7 squared, right? So I have 1 over 7 squared. That's not quite a common base, but remember, I can make the 1 over 7 squared the reciprocal 7 to the negative 2 power. Remember, reciprocals give you a negative exponent. So now I have a common base, and I can drop that base and equate the powers. So I end up with x squared plus 3x equals negative 2. This time this is a quadratic equation, so I'm actually going to get two solutions possibly. Let's see. So a quadratic equation we solve by setting everything equal to 0. Now I got to see if I can try to factor this thing. And I think plus 2 and plus 1 will work, because if you FOIL this out, you'll end up with x squared plus 3x plus 2, and so I end up with x equals negative 2 and negative 1 as solutions. So I get two different solutions here. Now really the trick was recognizing that 1 over 7 squared is the same thing as 7 to the negative 2 power. So remember, anytime you want to bring something to the numerator, you have to make the exponent negative. You have to flip the exponent. Alright, let's look at part E, because part E's got a trick here. I have 1 to the 3x minus 7 power equals 4 to the 2 minus x. And can I write these as a common base is the question. Well, yes. So remember that anything to the 0 power is 1. So that means here that the 1 is actually 4 to the 0 power to the 3x minus 7 equals 4 to the 2 minus x. And the 0 does something weird for us, because that means I have 0 times 3x minus 7 as an exponent equals 4 to the 2 minus x. And so I have 4 to the 0 equals 4 to the 2 minus x, which now, since I have common base, I can drop to have 0 equals 2 minus x, or x equals 2. Okay, now if you think about it, let's look at this for a second. If I plug that 2 back in the beginning, here I have 4 to the 0 power equals 1 to some power, but 1 to some power is going to be 1. Is 4 to the 0 1? Yes, remember we already said that. So this does check out. The trick is recognizing that 1 can be written as 4 to the 0 power. And that's a useful tool to have in your handbag. Make sure you keep up with that one. Alright, let's look at part F. So this time I have 3 to the 2x minus 7 power equals 81 to the x minus 2 power. Okay, 81 is one of those that's going to show up often. So remember that 81, this could be the same thing as 9 squared to the x minus 2 power. And 9 squared is the same thing as 3 squared. So we end up with 3 squared squared, or 3 to the 4th to the x over 2 power. And that's exactly what you're going to do. So I have 3 to the 2x minus 7 equals 3 to the 4th to the x over 2 power. So that's 3 to the 2x minus 7 power equals 3 to the 4x over 2, which I'll just write here. That simplifies, right, as 3 to the 2x power. So now I can drop my bases and just equate the exponents. So I have 2x minus 7 equals 2x. And when I subtract the 2x's from each side, I get negative 7 equals 0. Okay, that's going to be a problem, right? Does negative 7 ever equal 0? Of course not. So the problem is that this is an inconsistent equation. So there's no solutions here. And you may think for a second, how could that possibly be? What it's saying at the very beginning is that 3 to the 2x minus 7 equals 3 to the 2x. And so of course, 2x minus 7 can never equal 2x, which is what we came up with down here. Okay, so that makes sense that there would be no solutions in this case. The algebra just works out the way it works out, right? Okay, so equating common base is the first approach you should always apply to solving an exponential equation. Hopefully it'll work for you. If it doesn't, we'll have to look at some other tools to do that. But common base is a very powerful tool. Make sure you understand your exponent rules, and if you have questions on this, I'd be glad to help. Thank you for watching.